Welcome to this lesson. It's the follow-up to the Introduction to Matrices lesson. This is part two of this lesson. In this particular part of the lesson, we're going to focus on the second half, or the second objective, where students will be able to find the determinant of a square matrix and determine an inverse matrix. All right. In our activator, we talked a little bit about matrices. We saw that, and we also saw the first part of the instructional focus where we defined what a matrix is. We took a look at matrix operations, addition, subtraction, multiplying by a scalar, and then how to multiply two matrices together. All right, so we're going to continue on and discuss the identity matrix. We're going to look at inverses and determinants of matrices and what those are and how they're used. So let's begin by looking at the identity matrix. All right, we could have a matrix that is n by n, which we call the identity matrix, with ones on the main diagonal. That's starting in the upper left all the way down to the bottom right. If all of the numbers are 1 and all other values in the matrix are 0, all right, this is what we call an identity matrix. All right, and here's a few examples. An identity of a 2 by 2 matrix is just 1 0 0 1 as shown here, etc. We can see the different identity matrices for the different size matrices that we have. So what is an identity matrix? We know that how it's, how the numbers go, but what's the point? How does it work? Well, the identity matrix, if we multiply it times another matrix, we're just going to get the same matrix. It's like if you multiply the number 1 times 3, you get 3. You multiply the number 1 times 10, you get 10, right? When we multiply any number times 1, we get the same number. It's kind of the identity for multiplication is multiplying times 1. The identity matrix is what we use for to multiply times a matrix to have the result be the exact same matrix. So if we have a non-zero matrix and we multiply it by the identity matrix, we're going to get that same matrix. All right, so now here's something kind of interesting here at the end. It says if A is a non-zero real number, then the inverse of A, or A to the negative 1, is 1 over A. That's the multiplicative inverse of A. That's how we kind of undo multiplication. That's how we undo multiplication with just numbers, right? So if we multiply a number times its inverse, we get 1, right? So if I were to multiply, for example, 9 times 1/9, it would give us the identity, or 1. Well, the same works with our matrices. If we were to take a matrix, A, and we were to multiply it times its inverse, so if I said, matrix A times its inverse, which would be like A negative 1, it would give us the identity matrix. It's going to work the same way. So we can actually come up with this inverse matrices. So if we say, let A of ij be an n by n matrix, if there's a matrix B such that A times B is equal to B times A, which is equal to the identity, then B is that inverse. All right, just like, the inverse of, when I thought about 9, it was like 1/9, because when I multiply them together, it gave me the identity 1. If there's a matrix, so if I multiply A times some matrix and I get the identity, then that matrix here is just the inverse of A. All right, and you could verify an inverse by multiplying two matrices together. So, for example, if I have matrix A and matrix B, and I want to know, is B an inverse, or are they inverses of each other? Well, that would mean that when I multiply them together, I would get the identity matrix. And that's exactly what happens when we multiply these together. If I multiply, for example, the first row of A times the column of B, so it would be 3 times 1 plus negative 2 times 1, just gives me a 1. Then I said for the first row times the second column, so remember with multiplication, row times column, 3 times 2 is 6, negative 2 times 3, negative 6, 6 plus negative 6 is 0. We do this again for the next one. Negative 1 and 1 times 1 and 1. Negative 1 times 1 is negative 1. 1 times 1 is 1. We add them together, we get a 0. And then for the last one, It's that negative 1 and 1 times 2 times 3. Negative 1 times 2 is a negative 2. 1 times 3 is a positive 3. That gives us 1. Notice we now have the identity matrix. Because it's the identity, we know that A and B are inverses of one another. Now what's shown here at the bottom is the calculator screen for when you multiply these. Now, I haven't shown you this yet, but in our calculator, we can actually put in matrices. All right, we can put in matrix A, matrix B, and we can actually multiply them together and get the result. All right, if you notice right above here, right underneath the math button in yellow, we see this matrix button. So I could actually hit second x negative 1, and I have matrix A, matrix B, C, D, E, etc. We actually can come in and we can edit matrix A. All right, so the first thing it asks me for is what is the order of the matrix? Well, these matrices that we have are 2 by 2. So I'm going to say it's a 2 by 2. All right, and then let me clear the screen there. All right, in the top left, I have positive 3. I then have negative 2. So you can actually fill out the values in the calculator. All right, and we can set the values. Okay, so that's matrix A. Then I'm going to go back and I'm second matrix. I'm going to go over to edit. I'm going to edit matrix B. It's also going to be a 2 by 2. So you actually put in the values. Then 1, 2, 1, 3. All right. Then I go back. So I can quit out of that now. I have a clear screen. So now I can come back into matrix and I can say matrix A times. Then I go back into matrix, choose matrix B. And when I multiply them, what do I get? I get the identity. And so you can actually use your calculator to do this. So it's very helpful to have a graphing calculator to be able to plug in these values. And when we get into finding inverses and things like that, if you know how to use your calculator, it's going to save you a lot of time and work. And for some of them, it gets so complex that you're not going to be able to do it without a calculator. This comes to a point where you are absolutely going to need a calculator in order to make some of the more advanced computations with matrices. Some other interesting things that you can do is we could add matrices, subtract. You can do all of those other things as well with your calculator. Now, something that can happen with matrices is it's possible that a matrix doesn't even have an inverse. All right, and we call a matrix that does not have an inverse as singular. All right, a singular matrix has no inverse. Well, how might I do that? Well, if we think about what we already mentioned, is that when we multiply matrix A times matrix B, right? So I multiply these two matrices together, 6, 3, 2, 1 by some x, or let's actually use W, times W, X, Y, and Z. All right, so we have 4 different variables. Doesn't matter what they are at this point. I'm going to multiply them together, and I'm hoping to get the identity matrix. All right, now without knowing those values, we're just going to have to multiply these out. So when we do this, once again, I'm going to use different colors as I go through this. 6, 3 times WY. So it's going to be 6W plus 3Y. That's going to be what's in the top left corner. All right, the next one, we're going to use this green. It's going to give me, let me undo that last one, times the second column, 6x plus 3z. All right, we're going to use, now I'll use black, I guess. 2, 1 times WY, it's going to be 2W plus Y. And the last one, we'll go back to, say, blue. It's going to be 2, 1 with x and z. It's just going to be 2x plus z. This would be my matrix. Now, if we remember, in order for it to be an inverse, it would have to equal the identity. So at this point, I would know that the identity matrix, 1, 0, 0, 1, would have to equal 6w plus 3y, etc., right? And I could fill out the whole thing. Or I could just now say that 6w plus 3y would equal 1. I would also know that 6x plus 3z would equal 0. I would know that 2w plus y would have to equal 0, and I know that 2x plus z would have to equal 1. Well, the interesting thing here, all right, let's just take, for example, this last piece. If I multiplied both sides by 3, I would end up with 6w plus 3y. 0 times 3 is still 0. Is it possible for 6w to 3y equals 0 and 6w plus 3y to equal 1? Is that possible? The answer to that is no. That's not possible to happen. We wouldn't be able to get two different values for the exact same thing. Because of that, I know that this can't happen. There's no way that this resulting matrix can equal the identity matrix, meaning there is no inverse. All right, so that's a way we could prove that an inverse does not exist, and that's exactly what we show here. And so it doesn't have an inverse. Now, there's got to be an easier way to determine whether or not a matrix has an inverse, and there is. All right, and the simplest way to test if a matrix has an inverse is by looking at what's called the determinant. All right, the determinant of a matrix will help us to do that. All right, so what we do is we can say, all right, if AD minus BC, and you're like, well, what are AD and BC? Well, this AD minus BC, all right, is what we call the determinant of the matrix. All right, and if we take the values in a matrix and we label them A, B, C, D in a 4x4 as seen right here, I'm going to write it up here, A, B, C, and D. If we multiply A times D and we multiply B times C and we subtract, so AD minus BC, if that equals 0, then there is no inverse. All right? And if we wanted to find the inverse, a simple way to do it would be to take the determinant of a matrix and multiply it as shown here, and that would help us to find the inverse instantly of a 2x2 matrix. But notice, if AD minus BC is 0, we get something undefined because you can't divide by 0. And that's how we can use the determinant for a 2x2. So if the determinant is equal to 0, then there is no inverse. So let's actually look at that AD minus BC for that previous problem. AD is 6 times 1, which gives me 6, minus 3 times 2, which is 6. It's 0. Because it's 0, there is no inverse. So we're able to use this thing known as a determinant to show that there is no inverse. So now we ask ourselves to find the inverse matrix for a couple different matrices. But first off, we want to know, does an inverse exist? So step 1, find the determinant. I'm just going to write DET for determinant. If the determinant does not equal 0, then there is an inverse. So AD, 3 times 2, minus 4 times 1 is going to give me 2. 2 does not equal 0, therefore an inverse does exist. So now at this point we can say the inverse is going to be 1 over 2 times, all right, and let's reference back to that formula that we saw before, this D negative B negative C A. D negative B negative C A. And that's what we're going to multiply at times. So we're going to do D, which was 2, negative B is negative 1, negative C is just going to be negative 4, and A was 3. So we're just kind of reorganizing them based on the formula for an inverse of a 2x2 that we saw right here. All right, we plug them in, and then we multiply. We do half of 2 is 1. Half of negative 1 is negative 1 half. Negative 4 over 2 is just negative 2. And then 3 over 2. And this would be our inverse. If I wanted to prove that this is an inverse, I would then go through and I would multiply them and see, do I get the identity? All right. Another very simple way in which we could do this is we could come into our calculator. All right. And let's bring that back up. Bring up our calculator. We're going to turn that back on. Let's make sure our calculator is on. There it is. I'm going to go into my matrix. I'm going to edit matrix A because I want it, it's still a 2x2. I want it to have the values that we had before, 3, 1, 4 and 2, 4 and 2. Now, now I can go back in there, matrix. And now the interesting thing is, well, what do I do now? Well, now I can come into math and I can say, oh, well, what's the determinant of, go back in there, matrix A. Did we do that correctly? We did. We got 2. The determinant was 2. So far, so good. Then I could even say, I could then come back in here and I could say matrix A, and I want to know what's its inverse. So I hit that x negative 1 and I hit enter. And it gives me 1, negative 0.5, negative 2, and 1.5, which is exactly what we got. All right? So your calculator can give you the inverse and the determinant. Once again, the calculator is a very strong tool. You should be able to find the determinant and an inverse of a 2 by 2 matrix. You need to know how to do that. You may be asked to do that without a calculator. All right? But for part B in this problem, you're not going to be asked to do that without a calculator. If you were given this 3 by 3 matrix, all right, then you just go ahead and, come back in here. We would edit our matrix, all right? So I'm going to edit it. I'm going to say this is a 3 by 3. We're going to start out by putting in the values 1, 2, negative 1, 2, and I don't expect you to find a determinant of a 3 by 3. It's way more complex, and we didn't even teach you how. All right? I'm not asking you to find the inverse of a 3 by 3. What I am asking you to do is, can you put it into a calculator? All right? And then say math, get the determinant. Oh, whoops. Let me actually get out of this entry here. Say determinant of that matrix that we just put in there gives me negative 10. The determinant is negative 10, so it does have an inverse. So now I'm just going to go ahead and do matrix A, and then I'm going to hit this x negative 1 button, hit enter, and there's my inverse. I can find it just like that. If I wanted to then multiply that times, so now multiply that inverse times the original matrix, I should get the identity. And sure enough, I do. All right, so you need to be able to use a calculator to make computations finding inverses and determinants of matrices. So in that second part of the lesson, we expanded on the what we did in the first part, where we learned about how to use matrices to represent data and how to add and subtract, multiply, divide, right? Or not divide, but multiply. We also jumped into practical uses of matrices, etc. And then in the follow-up, in the second half, we just learned about this concept of identity and inverse matrices and how we can use a determinant to help us to solve problems. All right. So based on the first half and the second half, you should be able to use matrices to represent and solve problems, perform matrix operations, and determine if a matrix has an inverse. Using a calculator, you should also be able to find that inverse of a matrix, and you should be able to find the inverse of a 2 by 2 matrix without a calculator. All right. Hopefully you're able to do all those things and that you feel pretty comfortable with this basic, initial introduction into matrices. You now have the foundation to build on that as we move forward throughout the rest of this unit.